Hi, I'm Mina.
And I'm Yules.
Thanks for tuning in to Artificially Informed.
Picture this. It is 115,000 years ago. You are walking across the Arabian Peninsula, but you are not struggling through a harsh, scorching desert. You are actually walking through lush, towering green vegetation.
Right.
You're leaving deep, muddy footprints on the edge of this massive, shimmering freshwater lake. It's just a completely unrecognizable landscape compared to the arid dunes we see today.
It really is.
And just this week, archaeologists uncovered those exact fossilized footprints in the Nefud Desert of Saudi Arabia. I mean, those ancient steps in the mud are systematically rewriting like everything we thought we knew about human history.
It is a stunning visual, honestly, and it perfectly encapsulates the sheer volume of, structural paradigm shifts we are tracking today.
Yeah.
When we analyze the global news cycle from archaeological journals to geopolitical dispatches spanning this final week of April 2026, we are seeing the very foundations of our world being rewritten in real time.
Literally right now.
Exactly.
Yeah.
We are looking at a landscape that we desperately want to believe is as solid as concrete, but is in fact incredibly fluid.
And that fluidity is exactly the mission of our deep dive today. We are going to cut through the noise of the daily news cycle and really extract those structural changes.
We have to.
Right, because we are unpacking the shifting foundations of our world. We have groundbreaking archaeology, dismantling the human timeline, mind-bending quantum physics, redefining communication, extreme climate tipping points, altering oceanic conveyor belts, and highly volatile geopolitical standoffs under U.S. President Donald Trump that are fracturing decades-old international alliances.
The breadth of the data is massive, but, it all connects. We are going to examine the underlying mechanisms of these shifts.
Yeah, the how and the why.
Right. We are not just going to tell you that artificial intelligence is changing space exploration or that global supply chains are threatened. We are going to break down the physical architecture of the microchips and the geographic realities of the maritime choke points causing these disruptions.
Exactly. So if you are listening, settle in. You are the third person in this conversation today as we navigate this incredibly dense, fascinating web of information.
It's going to be quite a ride.
It really is. And to really grasp where we are heading with artificial intelligence and space-based solar power later on, we actually need to start with the dirt beneath our feet.
The best place to start.
Because those 115,000-year-old footprints in Saudi Arabia are completely destroying the old out-of-Africa timeline.
They absolutely do. I mean, for decades, the prevailing anthropological model, the single origin hypothesis, suggested a relatively neat, linear exodus.
Like a straight line.
Yeah, exactly. The assumption was that a single, isolated population of early Homo sapiens evolved in East Africa, and then, in a distinct late wave, migrated outward to populate the globe.
Right.
But finding human footprints at a site called Al-Athar, which actually translates to the trace in the Nefud Desert dating back 115,000 years, proves that migration was not a single event. It was a series of, opportunistic pulses.
Driven by the climate windows, right?
Yeah.
Because that region in Saudi Arabia goes through these massive cyclical shifts.
Precisely. The Arabian Peninsula experiences a phenomenon driven by the shifting of the Earth's axis and orbit. It creates periods known as Green Arabia.
Green Arabia, that just sounds wild.
It is. During these windows, the monsoon rains shift northward, transforming the desert into a massive network of grasslands and freshwater lakes.
Oh, wow.
Yeah, so early humans were simply following the expanding ecosystems. They weren't setting out to conquer a desert, they were just following the water in the game.
Which completely reframes human migration. I mean, we weren't these uniquely determined explorers marching into the wasteland. We were just part of a dynamic, shifting biosphere.
Exactly.
And that idea of a complex, messy human history brings us right to the new DNA research out of the African continent itself. Scientists have been doing complex genetic analyses on diverse groups, specifically looking at the genetically unique Nama people, an indigenous group in southern Africa.
Right.
And they're combining this with a technique called environmental DNA, or ancient soil genetics.
Environmental DNA extraction is, without a doubt, one of the most profound technological leaps in modern archaeology. It acts, quite literally, as a time machine.
Okay, I had to ask about the mechanics of this because it sounds impossible. How do you extract human DNA from dirt?
It's tricky.
I imagine a cave floor is covered in the DNA of every worm, bat, bacteria, and fungus that has lived there for the last 100,000 years. How do they isolate the genetic ghost of a human?
It is an incredibly meticulous process of molecular fishing. When organic material, skin cells, hair, bodily fluids decays in soil, the long strands of DNA break down into microscopic fragments.
Okay.
But certain minerals in the soil, particularly quartz and clay, can actually bind to these DNA fragments, shielding them from complete degradation.
Like a microscopic vault.
Exactly. So scientists take core samples of this ancient dirt in sterile labs. They use chemical solutions to unbind the DNA from the minerals.
And what about the bat and worm DNA?
Right. To solve the worm and bat problem, they use synthesized probes. These are essentially magnetic, lab-created strands of DNA that are programmed to only match and attach to specific human genetic sequences.
Wait, so they drop in these synthetic magnets and they only pull out the human pieces from the biological soup.
That's exactly how it works.
That is brilliant.
It is. And once they sequence those fragments, they can map the genomes of populations that never left behind a single fossilized bone.
Unbelievable.
And what they found, particularly when analyzing these ancient soil samples alongside the modern genomes of the Nama people, completely dismantles the single population theory.
How so?
The genetic data proves that early Homo sapiens did not evolve from one localized group. We evolved from at least two, and likely many more, distinct populations spread across the African continent.
Really?
Yeah, populations that were constantly intermingling, splitting apart, and recombining over hundreds of thousands of years.
So it's not a single solo artist starting a world tour. It's more like a massive continent-wide jam session.
I love that analogy.
We were this interconnected network swapping survival traits. And, this wave of historical revision isn't just biological, it's cultural too. Let's look at Easter Island, geographically known as Rapa Nui, out in the southeastern Pacific Ocean.
Ah, yes. The dating of the Rongorongo script. This is a monumental shift for linguistics.
For anyone unfamiliar, Rongorongo is a system of glyphs carved into wooden tablets found on Rapa Nui. The long-held assumption was that the indigenous people only developed this writing system after European explorers, specifically the Spanish, arrived in the 18th century. The narrative was essentially that the Rapa Nui saw Europeans writing and just decided to mimic the concept.
Which has always been a remarkably Eurocentric assumption, predicated on the belief that isolated indigenous populations lack the capacity for independent, complex literacy.
Right. But now researchers have used accelerator mass spectrometry to test one of these tablets stored in a museum in Rome.
Yes.
And the results show the wood dates back to the mid-15th century. This is hundreds of years before any known European contact.
Which changes everything.
But how does this specific dating method work? I know carbon dating has been around for a long time, so why is this accelerator mass spectrometry AMS suddenly giving us these breakthroughs?
Well, traditional radiocarbon dating requires a fairly substantial chunk of the artifact to be burned and destroyed to measure the radioactive decay of carbon-14.
Oh, which you definitely cannot do with a priceless wooden tablet.
Exactly. When you are dealing with an incredibly rare, delicate carving, museums are obviously not going to let you burn a piece off. So AMS solves this through physics.
Okay.
Instead of waiting for the carbon to decay and measuring the radiation, an AMS machine extracts a microscopic pinhead-sized sample. It vaporizes it, ionizes the atoms, and accelerates them through a massive magnetic field at incredible speeds.
Like a particle accelerator for history.
Exactly like that. Because carbon-14 has a different atomic mass than regular carbon-12, the magnetic field bends their trajectories differently.
Oh, that makes sense.
Right. And the machine physically counts the individual carbon-14 atoms one by one. This extreme precision allows them to accurately date a tiny sliver of the wood without damaging the script.
And by proving the wood predates European arrival, it strongly suggests the Rapa Nui developed their own localized tradition of writing entirely on their own.
It completely shatters the narrative of reactive innovation.
It proves human ingenuity isn't localized to a few specific continents. And, while we are rewriting human history, we are also actively rewriting planetary history.
We really are.
Geologists have just published isotopic analysis of meteorites, proving that Earth primarily formed from materials found in the inner solar system.
Which is a significant deviation from competing models.
Right.
There was a strong theory that as the giant gas planets like Jupiter migrated during the early days of the solar system, they flung massive amounts of water-rich material from the outer, colder regions inward, and that this material formed the bulk of the Earth.
Okay, wait. If the isotopic signatures in these meteorites definitively prove we are made of inner solar system rock, I see a massive paradox here.
You've spotted it.
We know the early inner solar system was incredibly volatile. It was hot, it was dry, it was blasted by solar radiation. If we formed from that dry rock, how on Earth do we get all of our oceans? Did the water come later from comets?
That is the exact contradiction planetary scientists are wrestling with right now. If the isotopic signature says inner solar system, but the inner solar system was theoretically too hot for water to condense into the planetary building blocks, the water delivery mechanism becomes a profound mystery.
So what's the new theory?
The current leading hypothesis to reconcile this is that the Earth was remarkably efficient at trapping what little water did exist in those inner rocks.
Trapping it how?
Instead of boiling away, the water molecules were locked inside the crystalline structure of the minerals, buried deep in the mantle as the planet accreted. Then, over billions of years, extreme volcanic activity slowly outgassed this trapped water vapor, which condensed to form the oceans.
So the oceans were baked inside the rocks from the very beginning. The Earth essentially sweated out its own oceans.
That's a great way to put it.
That is wild. And speaking of the chemical structure of rocks, geologists just solved a mystery that has baffled them for 200 years. The dolomite problem.
2 centuries of scientific frustration finally resolved.
Yeah.
Dolomite is a complex mineral, an intricate alternating layering of calcium and magnesium carbonate. It is incredibly common in nature. Entire mountain ranges, like the Dolomites in Italy, are made of it.
Right. It's everywhere.
It forms effortlessly in ancient marine environments. But for 200 years, scientists have been completely unable to synthesize it accurately in a laboratory at room temperature.
Every time they tried to grow it, the crystalline structure would fail, right?
Right.
It would just collapse into chaotic defects.
Exactly.
Why was nature able to bake this complex layered mineral effortlessly, but our most advanced labs couldn't?
It comes down to the physics of crystal growth and surface free energy. When dolomite tries to crystallize rapidly in a lab, the calcium and magnesium atoms rush to attach to the growing crystal lattice.
Like building a brick wall too fast?
Yes, and they often attach in the wrong spots. When an atom attaches incorrectly, it creates a defect. These defects cause the surface energy of the crystal to spike, which physically blocks subsequent layers from forming correctly.
Oh, I see.
The crystal basically chokes on its own rapid growth. What researchers discovered using advanced atomic force microscopy is that in nature, the crystal grows, but then mild fluctuations in the environment, like a slight change in acidity or a period of dissolution, actually wash away the defects on the surface before the next layer forms.
It's like proofreading a document. Nature writes a sentence, erases the typos, and then writes the next sentence. But in the lab, we were just forcing it to write the whole book at once, and it turned into gibberish.
A perfect analogy. By cycling the chemical environment in the lab, alternating between periods of crystal growth and periods of slight chemical dissolution, they finally synthesized perfect, stable dolomite at room temperature.
Wait, if they can synthesize dolomite in a lab now, this isn't just about solving an old geology puzzle. Dolomite is a carbonate. It naturally locks away carbon.
You see where this is going?
If we can mass produce this using industrial processes, we could theoretically manufacture construction aggregates that suck carbon right out of the atmosphere. We could build cities out of carbon sinks.
That is the exact commercial application being explored, and we desperately need scalable carbon sequestration because the Earth is actively reacting to the current atmospheric load.
Very actively.
In fact, the Earth is reacting on a tectonic level. If we look at the Turkana Rift in East Africa, the continental crust is visibly thinning.
The geological term is necking, right?
Yes, necking. Imagine pulling apart a piece of warm taffy. It thins out in the middle before it snaps.
That's quite a visual.
The African continent is actively tearing apart along the East African rift system. Magma is pushing up from the mantle, stretching the crust to a critical point.
Wow.
Over the next few million years, that rift will eventually drop below sea level, the ocean will flood in, and Africa will be split into 2 distinct land masses with a new ocean basin between them.
It's a humbling reminder that the map of the world is just a temporary snapshot. But while tectonic plates move over millions of years, the atmosphere above those plates is undergoing unprecedented rapid-fire changes right now.
Yes.
The extreme tipping points.
We are seeing the Earth's ecosystem reacting drastically to human-induced thermal loading. A prime example is the report from the University of Oslo detailing the hemispheric heat divide.
Right, the northern hemisphere is warming significantly faster than the southern hemisphere.
And this isn't just a slight statistical variance, it's a massive, observable divergence.
But why is the top half of the planet cooking so much faster than the bottom?
It comes down to basic thermodynamics and the distribution of land versus water. The northern hemisphere contains the vast majority of the Earth's landmass, North America, Eurasia, parts of Africa.
Right.
The southern hemisphere is dominated by vast, deep oceans. Water has a much higher specific heat capacity than soil or rock.
So it absorbs more heat without getting as hot.
Exactly. It requires significantly more thermal energy to raise the temperature of the ocean than it does to heat up a continent. Therefore, the north is heating up rapidly like a frying pan on a stove, while the south is acting as a massive thermal buffer, absorbing the heat without dramatically raising its surface temperature.
But the atmosphere doesn't like imbalance. It constantly wants to equalize.
Yeah.
So if the north is a frying pan and the south is a cooler pool, that has to be violently altering global weather patterns.
And it is severely disrupting the jet streams. The polar jet stream in the north is driven by the temperature differential between the cold Arctic and the warmer equator. But because the Arctic is warming up to 4 times faster than the rest of the globe, part of this hemispheric divide, that temperature differential is weakening.
And when that differential weakens.
The jet stream slows down and becomes wavy and erratic. It meanders. This is the exact mechanism causing prolonged, extreme weather events.
Like heat domes.
Yes, heat domes get trapped over cities for weeks because the jet stream isn't strong enough to push them away, or torrential storm systems stall out and cause catastrophic flooding.
And we are pouring gasoline on that erratic fire with the Pacific Ocean. Meteorological reports are showing a strong El Niño developing, and scientists are warning it threatens to push the entire globe past the critical 1.5 degrees Celsius warming threshold.
This is where we cross from standard climate change into climate regime shifts.
That sounds ominous.
It is. El Niño is a natural, cyclical warming of the central and eastern tropical Pacific Ocean. It releases massive amounts of oceanic heat into the atmosphere. When you combine the baseline thermal load of human greenhouse gas emissions with the natural thermal spike of a strong El Niño, you risk crossing thresholds that fundamentally and permanently alter baseline climate states. Ecosystems simply cannot adapt fast enough to a sudden step function increase in global temperatures.
And we are already seeing those localized collapses. The report out of Central America is terrifying. For the first time in 40 years, the Gulf of Panama's ocean lifeline just vanished.
The failure of the oceanic upwelling.
Right. Let's break down the physics of this because it's the conveyor belt of the ocean. Normally, strong trade winds blow across the surface of the water, pushing the warm surface water away from the coast of Panama. This physical displacement acts like a vacuum, pulling up deep freezing nutrient-rich water from the bottom of the ocean to replace it. Those deep-sea nutrients are what feed the entire ecosystem.
Exactly.
But this year, because of the erratic climate shifts we just talked about, those trade winds were incredibly weak. The vacuum never turned on, the upwelling just stopped.
And the cascading biological effects of an upwelling failure are immediate and devastating. Without those deep-sea nutrients, the phytoplankton populations at the surface completely collapse.
Because they have no food.
Right. Phytoplankton are the foundation of the marine food web. Without them, small forage fish starve. Without the small fish, larger predatory fish migrate away or die off.
It's a chain reaction.
A very fast one. The coastal communities in Panama that rely on that marine ecosystem for their physical survival and economic stability face immediate ruin.
And the global supply chain for seafood is highly integrated. If the Panama upwelling fails, and similar upwelling zones off the coast of California, West Africa, and Peru are also vulnerable to these weakening trade winds, we're looking at a systemic shock to global marine food webs.
Absolutely.
The price of seafood in Europe or Asia skyrockets, and millions of people lose their primary source of protein. It shows how delicate the balance is. Which brings us to the danger of trying to engineer our way out of this with a sledgehammer. Let's look at China's massive reforestation effort.
It is the ultimate lesson in the law of unintended consequences in geoengineering.
You hear the headline, China planted 78 billion trees, and your first reaction is, that is an incredible triumph for climate change.
Naturally.
But treating complex ecosystems like simple math equations, assuming more trees always equals a better environment, is dangerously reductive. I think of it like human nutrition.
How so?
Just because a little iron is essential for your blood doesn't mean eating a massive concentrated bowl of iron filings won't completely destroy your internal organs.
A very visceral but accurate biological analogy. In China's case, they engaged in a massive state-sponsored effort to combat desertification, planting billions of trees across regions like the Loess Plateau, which were historically semi-arid grasslands.
Okay.
But trees require immense amounts of water. As these vast, dense new forests matured, they engaged in intense evapotranspiration.
Which means?
They essentially acted as billions of giant biological straws, driving deep into the soil, sucking up the limited groundwater and transpiring it directly into the atmosphere as water vapor.
So they created a massive canopy, but they absolutely devastated the regional water cycle. River runoff in these regions plummeted because the trees were intercepting all the moisture before it could reach the rivers.
Yes, exactly.
They left downstream communities and agriculture completely parched. It is a stark reminder that you can't just drop a forest onto a landscape without intimately understanding the local hydrology and planting native, water-appropriate species.
Nature is a complex web of dependencies, and when thermal barriers break down, that web gets invaded. We are seeing this vividly in Iceland.
The mosquitoes. This is one of those stories that sounds minor until you realize what it signifies.
It signifies a lot.
For centuries, Iceland has been famous for being entirely devoid of mosquitoes. Its freezing, highly erratic winters and incredibly short springs prevented the insects from ever completing their pupal life cycles. It was a protected, isolated biome. But recently, researchers found the first 3 mosquitoes, identified as Sculiceta annulata, established in the country.
3 insects shatter a national record, and the mechanism is entirely thermal. Unseasonably warm springs and milder winters have dissolved the temperature barrier that protected the island.
Right.
If mosquitoes can establish a sustainable breeding population, it radically alters the competitive dynamics of the native ecosystem. But more troublingly, from a human perspective, it introduces a biological vector for disease that the local wildlife, livestock, and human population have absolutely zero historical immunity against.
It's a biological invasion facilitated by the climate. And dealing with all of these cascading effects, failing fisheries, shifting water tables, invasive vectors, requires massive amounts of capital. Which brings us to the severe climate finance crisis developing at the UN.
The Loss and Damage Fund. This is a critical point of geopolitical tension.
The United Nations backed this specific fund to help developing nations deal with the immediate impacts of climate change. But the executive director, Ibrahima Sheikh Diong, just issued a stark warning.
Yes, regarding liquidity.
Right. They are facing severe liquidity issues by 2027. Wealthy nations pledged $822 million, but they have only actually delivered $449 million.
It is a profound operational failure that highlights the deep divide between the global north and the global south.
Which is a massive problem.
Developing nations, which historically contributed a tiny fraction to global industrial carbon emissions, are bearing the brunt of the physical impacts. Floods, droughts, upwelling failures. They are facing an estimated $400 billion annually in climate-related damages.
$400 billion.
Yes. The UN fund was supposed to be a diplomatic lifeline. But if the wealthy nations fail to deliver the pledged capital, the fund is paralyzed, and trust in international climate agreements collapses.
There's a push to bypass the reliance on external funds by fundamentally changing the energy architecture. Down in South America, Colombia is hosting a massive renewables conference right now. The Science Panel for the Global Energy Transition in Santa Marta.
A very important gathering.
You have 50 country delegations there, and they are trying to create actionable, science-based roadmaps to transition completely away from fossil fuels, heavily backing the Fossil Fuel Treaty Initiative.
What is particularly notable about the Colombia summit is the evolving rhetoric. Colombia's environment minister, Susana Mohammed, and other leaders are framing the transition not just as an environmental necessity, but as a hard-nosed geopolitical security measure.
Oh, so?
Historically, the global reliance on fossil fuels has necessitated alliances with, or vulnerability to, authoritarian regimes that control oil reserves. By transitioning to localized renewable energy grids, nations are attempting to decouple their economies from the volatility of global oil markets. It is being framed as a democratic imperative.
Which is the perfect transition, because as the planet's ecological systems strain, the fight for control over the remaining traditional resources and the strategic choke points that transport them is boiling over into acute global conflict. The volatility we see in the climate is mirroring the volatility on the geopolitical chessboard.
And we must approach this geopolitical segment with strict analytical impartiality.
Exactly.
The situations unfolding globally involve high-stakes military posturing, shifting alliances, and complex diplomatic maneuvering. We will examine the mechanics of these standoffs and their global implications.
Let's start with the absolute powder keg that is the Strait of Hormuz in the Middle East. We are witnessing a massive, escalating standoff. Both the United States and Iran have initiated blockades in this vital waterway.
It's an incredibly tense situation.
U.S. President Donald Trump has taken a highly aggressive public stance, explicitly threatening lethal force, using the phrase shoot and kill, against any Iranian boats alleged to be laying mines in the strait. The U.S. is maintaining a tight blockade of Iranian ports, while Iran is demanding the immediate lifting of all U.S. economic sanctions.
To grasp the severity of a standoff in the Strait of Hormuz, one must understand its unique geographic and economic role. It is the quintessential maritime choke point. It is a narrow stretch of water between the Persian Gulf and the Gulf of Oman, flanked by Iran to the north and Oman and the United Arab Emirates to the south. Approximately 20% of the world's global oil consumption and massive volumes of liquefied natural gas flow through that specific narrow corridor.
20% of global energy, bottlenecked in a zone currently occupied by two hostile militaries threatening lethal force. It's terrifying.
When military vessels engage in blockades, intercept container ships, and issue direct threats of deadly force in a choke point of that magnitude, the global supply chain registers an immediate severe shock.
Which we're already seeing.
Yes, we are already seeing Brent crude prices surge past $100 a barrel. This localized maritime standoff has immediate downstream effects on global logistics. It drives up the cost of diesel for shipping, which increases the cost of manufacturing, which directly fuels global inflation. It impacts the price of basic goods for listeners everywhere.
And the avenues for de-escalation seem to be systematically collapsing. There was a planned diplomatic back channel. A U.S. delegation led by Jared Kushner and Steve Witkoff was scheduled to travel to Islamabad, Pakistan, to negotiate indirectly with the Iranian Foreign Minister Abbas Araghchi.
That was the plan?
But U.S. President Donald Trump abruptly canceled that trip.
Yeah.
In response, Araghchi is now in Russia, holding high-level meetings to strengthen Iranian-Russian strategic ties. Furthermore, Trump has publicly stated his administration's goal is to entirely abolish Iran's nuclear stockpile.
The cancellation of the Islamabad talks indicates a severe deterioration in diplomatic flexibility. By pivoting to Moscow, Iran is executing a classic great power balancing act.
Seeking support elsewhere.
Right. Facing intense pressure and a blockade from the United States, Tehran is seeking to leverage its strategic and military alliance with Russia, potentially seeking advanced weaponry or economic bypasses to counter the U.S. sanctions. Meanwhile, the U.S. rhetoric demanding the total abolition of the nuclear stockpile signals a maximalist policy approach.
Meaning what, exactly?
In diplomatic negotiations, demanding total capitulation leaves very little room for the incremental compromises that usually de-escalate these types of crises.
And this maximalist hardline approach isn't just isolating Iran. It is causing massive internal fractures within NATO itself. This is where the geopolitical tectonic plates are truly shifting. A leaked internal Pentagon document suggested that the U.S. might reconsider its military and diplomatic stance regarding the United Kingdom's sovereignty over the Falkland Islands. And the explicit reason given was because the U.K. did not join the U.S. in its military blockade actions regarding Iran.
Which represents a profound and highly controversial weaponization of diplomatic leverage within an alliance. The Falkland Islands, located in the South Atlantic, have been a point of intense historical and military contention between the UK and Argentina, culminating in the 1982 war.
Right.
For the United States to quietly suggest that its foundational support for British sovereignty might be conditional on British participation in a completely unrelated Middle Eastern conflict is a massive shock to the core tenets of the special relationship.
No 10 Downing Street had to immediately push back, asserting their sovereignty over the islands remains absolute and non-negotiable.
Yes.
It essentially turns a core ally's territorial integrity into a bargaining chip. And it wasn't just the UK. Another report surfaced indicating the US might try to seek the suspension of Spain from NATO, again, over their reluctance to adopt the U.S. stance on Iran.
Which caused quite a stir.
The rhetoric got so heated that NATO officials in Brussels had to formally clarify that there is legally no provision in the NATO founding treaty to expel a member state.
The legal framework of the North Atlantic Treaty does not contain a mechanism for expulsion. However, the fact that such threats are being floated internally points to a deep structural strain on alliance cohesion. NATO is built on the principle of collective defense in the Euro-Atlantic area. If major members begin threatening each other's territorial integrity or alliance status over foreign policy disagreements in the Persian Gulf, it fundamentally transforms the nature of the alliance. If collective defense becomes transactional rather than guaranteed, the deterrence value of NATO fractures.
It's an incredibly fragile moment.
Mm.
But while military leverage is being tested, the major powers are also fighting an entirely different kind of war, an economic one.
Yes, a very quiet but critical war.
The U.S. and the European Union just signed a massive critical minerals pact, spearheaded by U.S. Secretary of State Marco Rubio and EU Trade Commissioner Maros Sefcovic.
This U.S.-EU Critical Minerals Pact is arguably the most consequential yet least discussed structural shift happening globally. It is the battle for the industrial architecture of the future.
Because it's designed specifically to break China's monopoly on the supply chain, right? Let's unpack the mechanics of this monopoly. Why is it so hard to just dig our own minerals?
Because digging the ore out of the ground is only the first and arguably the easiest step. China currently dominates not just the mining, but more importantly, the highly complex, chemically toxic, and energy-intensive processing and refining of critical minerals.
Like lithium and cobalt.
Yes, lithium, cobalt, rare earth elements. These refined materials are the absolute non-negotiable ingredients for the batteries in electric vehicles, the processors in smartphones, and the guidance systems in advanced weaponry. The US and EU have recognized that relying on a strategic competitor for the fundamental building blocks of both the green energy transition and military technology is an unacceptable vulnerability.
So this pact is them trying to build an entirely parallel supply chain from scratch, coordinating trade policies, aligning environmental regulations so they can share refined materials, and heavily subsidizing domestic refining industries. They're trying to decouple their technological future from Chinese leverage.
Precisely. And while the major powers engage in this high-stakes economic decoupling, regional stability in heavily resourced developing areas is collapsing.
It's a grim picture.
We are seeing a horrific surge in violence in Mali, in West Africa. A massive, highly coordinated jihadist attack hit several strategic locations, including the capital, Bamako. During this wave of violence, the Malian defense minister, General Sadio Kara, was killed following a suicide car bombing at his residence.
It's a complete decapitation of the military leadership, and the geopolitical ripple effects are immediate. Following these attacks, which reporting indicates involve both al-Qaeda-linked insurgent groups and Tuareg separatists, Russian mercenary forces confirmed they are officially withdrawing from the northern Malian city of Kidal.
The withdrawal of those mercenary forces creates a massive, highly dangerous power vacuum.
Why were they there in the first place?
The Malian military junta had heavily relied on these Russian paramilitaries for core security functions after intentionally expelling French military forces and the UN peacekeeping mission over the past few years.
Oh, I see.
The sudden withdrawal of the mercenaries from a contested northern stronghold, coupled with the assassination of the defense minister, severely compromises the state's physical ability to maintain territorial integrity. It is a vivid illustration of the fragility of state security when it is outsourced to external mercenary entities during a complex, multi-front insurgency.
And that volatility, that breakdown of order, isn't just isolated to conflict zones or international straits. That exact same tension is spilling over into the domestic sphere here in the U.S. It is targeting the very institutions meant to represent stability and safety.
The domestic incidents reported this week are deeply unsettling, highlighting breaches in highly secured environments. Again, approaching this strictly through an analytical lens, the implications for public trust are severe.
A horrific shooting occurred in Washington, D.C., at the Washington Hilton, during the annual White House Correspondents' Dinner. The suspect, identified as Cole Thomas Allen, who disturbingly referred to himself in online writings as a friendly federal assassin, charged into the ballroom area and opened fire.
A terrible tragedy.
Authorities say he was allegedly driven by severe political grievance and was targeting administration officials.
The White House Correspondents' Dinner is one of the most high-profile, heavily guarded social events in the Capitol. It is attended by the president, cabinet members, elite media figures, and foreign dignitaries. It represents a nexus of political and media power.
U.S. President Donald Trump was in attendance, though he was unharmed, and later stated to the press that he wasn't worried. But the analytical question remains. With the Secret Service and local law enforcement creating massive perimeters, how does an armed individual calling himself a federal assassin get into a room full of the most guarded people on Earth?
It forces security agencies to confront the grim reality of the insider threat or the sophisticated, grievance-driven lone actor. When an individual is highly determined to commit violence, even the most robust physical perimeters can be breached if there is a systemic failure in intelligence gathering, threat assessment, or credential verification.
Because they find a loophole.
Exactly. If an attacker possesses legitimate or perfectly forged credentials to bypass outer checkpoints, the physical security presence is compromised. The psychological toll of this event on society is
I
massive.
can imagine.
If a gala populated by the highest levels of government isn't safe, it fundamentally alters how leaders interact with the public. We are likely looking at a future where public events become entirely closed off, creating an insurmountable physical wall between the press, politicians, and the citizenry.
And tragically, the concept of a safe space was violently breached elsewhere as well.
Yeah.
In Chicago, Illinois, at the Swedish hospital in Roseland, 2 police officers were shot in an ambush-style attack, leaving one critically injured.
Healthcare institutions and public service roles are increasingly finding themselves on the front lines of societal fracture. A hospital is inherently designed to be an open, accessible place of healing. When police officers are attacked within those walls, it highlights the unpredictable nature of urban violence. It underscores the acute daily dangers faced by law enforcement, and it violently erodes the fundamental trust required for civic infrastructure to function. When hospitals and political dinners become sites of violence, the structural foundation of a stable society feels incredibly fragile.
It really does. It feels like our human political and social systems are fracturing under the weight of all this stress. But, and this is a massive pivot, while our social systems struggle, human ingenuity in the realms of science and technology is accelerating at a breakneck, almost terrifying speed.
It's moving incredibly fast.
The bleeding edge of tech is moving so fast it feels like magic.
The acceleration in computing, specifically in the realm of artificial intelligence, is no longer incremental. It is exponential, and it is actively restructuring the global economy.
Let's examine the AI compute grab because the financial scale is staggering. Google just announced they're investing up to $40 billion with a B into Anthropic, an AI safety and research company,
Yeah.
$40 billion in cash and direct compute power.
To understand the sheer gravity of a $40 billion investment, you must understand the physical reality of the AI industry. Compute is the new essential resource.
What does compute actually mean in this context?
It refers to the physical processing power, the highly specialized hardware, like Google's custom tensor processing units, or TPUs, and advanced NVIDIA chips, required to train and run massive large language models like Anthropic's Claude. Training an AI requires running trillions of calculations simultaneously. That requires warehouses full of chips.
So that $40 billion isn't just Google handing over a check. It is a desperate strategic grab to monopolize the physical infrastructure of the future. Google is buying a foundational stake in the next technological era, ensuring that Anthropic's models run on Google's silicon.
Exactly. It is infrastructure capture.
But what I love is that it's not just the mega corporations playing this game. The secondhand consumer market is going absolutely crazy right now. People are flooding eBay, hoarding old Apple Mac minis at massive markups.
It's a fascinating phenomenon.
Why? Because developers realize they don't need a massive server farm to run localized AI. They just need the right architecture.
It is a fascinating clash between the democratization of AI development and global supply chain realities.
Let's break down why the Mac Mini specifically is the holy grail right now. It comes down to Apple's unified memory architecture. In a traditional PC setup, you have your main processor, the CPU, over here, and your graphics card, the GPU, over there. They each have their own tool of memory.
Right.
If the AI wants to calculate something, it has to constantly shuttle data back and forth across the motherboard between the CPU and the GPU. It creates a massive bottleneck.
And AI processing, which requires massive data sets to be held in active memory, chokes on that bottleneck.
Right. But Apple's silicon puts the CPU, the GPU, and a massive pool of high-speed memory all on the exact same physical chip. It's like a kitchen where the fridge, the stove, and the cutting board are all within arm's reach of the chef.
That's a great visual.
The AI doesn't have to wait to fetch data. It can access everything instantaneously. This means developers can run surprisingly powerful open-source AI models right on their desks in their bedrooms.
It's a grassroots technological movement. The developers buying these machines aren't trying to build the next trillion-parameter ChatGPT. They're building highly specialized, localized models. The hardware is the ultimate enabler.
And speaking of hardware enabling the impossible, let's look at astronomy. The JWST, the James Webb Space Telescope, has been sending back breathtaking images of the deep cosmos.
Truly incredible images.
But historically, the raw data coming back from these deep space observatories is so dense that it takes human astronomers years of painstaking calculation to identify patterns or exoplanet signatures. Now, researchers have implemented advanced AI algorithms that have reduced the data analysis time for the James Webb from years down to days.
The mechanism here is pattern recognition at scale. AI models excel at sifting through massive, noisy datasets and identifying the microscopic anomalies. A tiny dip in a star's light curve, a specific infrared signature that indicate the presence of a planet or a distant galaxy.
So it's doing the tedious work.
By reducing the analysis time to days, it fundamentally alters the pace of astronomical discovery. Furthermore, it is a necessary preparatory step for the upcoming Rubin Observatory, which will scan the entire visible sky every few nights.
Oh, wow.
The Rubin will generate so much raw data that human analysis would be mathematically impossible. AI is transitioning from an analytical tool to our primary lens for viewing the cosmos.
We are training machines to look at the stars for us. And while AI maps the universe, quantum physicists are completely rewriting the rules of light right here on Earth. Scientists just published a paper detailing the creation of optical tornadoes.
Torans. A truly remarkable breakthrough in optical physics.
Let's break down the mechanics, because it sounds like science fiction. They used highly specialized liquid crystals to physically twist beams of light into stable microscopic whirlwinds.
Yes.
But why does twisting a beam of light revolutionize global security? Why does it create unhackable quantum communication?
It is rooted in the fundamental laws of quantum mechanics, specifically wave-particle duality and the observer effect. Traditional encryption relies on incredibly complex mathematics, but a sufficiently powerful computer like a mature quantum computer could eventually brute force those mathematical locks.
Right.
Quantum communication, however, relies on physics. When you twist light into these stable torons, you are encoding information into the quantum state of the photons themselves.
And the quantum rule is,
Well,
you cannot measure a quantum system without altering it.
Exactly. If an adversary tries to intercept or hack this optical tornado, the very act of them observing or measuring the photons causes the quantum wave function to collapse.
Oh, so it breaks it.
The physical state of the light instantly changes. The receiver immediately knows the message has been tampered with because the tornado arrives broken. It is a communication system secured by the physical laws of the universe, rendering it theoretically unbreakable by any computational force.
Which poses an incredible geopolitical question. What happens to the global intelligence apparatus when the NSA or foreign spy agencies can literally no longer intercept or decrypt communications? It changes the entire paradigm of espionage.
It absolutely does.
And speaking of changing paradigms, Europe is actively trying to restructure its entire digital landscape. They're aggressively pushing to ditch U.S. software.
The drive for sovereign tech.
The European Union has realized that relying entirely on American tech giants, Silicon Valley cloud storage, U.S.-based AI models, American communication platforms, is a massive strategic vulnerability. They want technological sovereignty. They're funding domestic open source alternatives. Are we looking at a future with a digitally fractured West where Europe and the U.S. have completely different walled-off internets?
It is highly probable. The European ambition for technological sovereignty is not merely economic protectionism. It is a fundamental matter of governance and public safety. Europe wants to guarantee that its citizens' data, its critical infrastructure, and its digital public square are subject strictly to European privacy laws like GDPR, and not the corporate policies of American tech monopolies.
That makes a lot of sense from their perspective.
This digital decoupling could lead to significantly divergent, incompatible technological ecosystems within the next decade.
And while governments argue over who controls the digital world, physicists are still trying to figure out what the physical universe is even made of. Let's talk about dark matter. A team of undergraduate students, which is incredible on its own, just built a cosmic radio, specifically designed to listen for hypothetical dark matter particles called axions.
It is a wonderful testament to the growing accessibility of experimental physics. But the theoretical shifts occurring alongside it are even more profound. Researchers have just published a major study suggesting a completely new origin story for dark matter. The traditional assumption was that dark matter was simply present at the Big Bang. But this new hypothesis suggests that gravitational waves, literal ripples in the fabric of space-time surging through the extremely hot, dense early universe, might have physically forged dark matter.
Wait, so the violent shaking of the early universe generated the dark matter?
That is the math they are proposing. As the primordial universe expanded violently, the intense gravitational waves caused fluctuations in the quantum fields, effectively coalescing energy into the elusive dark matter particles that now hold our galaxies together. It elegantly bridges the gap between gravitational phenomena and cosmic evolution.
And if that wasn't enough to melt your brain, a completely separate team of particle physicists just discovered an exotic particle that might finally explain the exact mechanism of why matter has mass at all.
A fascinating discovery.
Now, I have to clarify something because my baseline physics knowledge says the Higgs boson is what gives things mass. How is this new exotic particle different?
That is a crucial distinction. The Higgs field does give mass to fundamental, indivisible particles like quarks and electrons. However, the protons and neutrons that make up the nucleus of atoms, which accounts for 99% of the mass of your body and the visible universe, are composite particles.
Okay, composite particles.
They are bags of quarks glued together by the strong nuclear force. The sheer kinetic energy and interaction of the strong force inside those protons and neutrons is actually what generates the vast majority of their mass, thanks to EMC squared.
Oh, wow.
This newly discovered exotic particle provides unprecedented insight into how those strong force interactions dynamically generate the mass of the everyday world. The Higgs gives mass to the pieces, but this strong force interaction gives mass to the whole.
It's incredibly humbling. We are building AI that can map the cosmos. But we are only just now understanding the fundamental physics of why our own hands have weight. But that lack of complete understanding doesn't stop us from pushing outward, because our physical reach into space is expanding to match our technological ambitions.
And our ambitions are shifting from observation to highly complex, sustained operations.
Exactly. Look at NASA, the National Aeronautics and Space Administration, and their Artemis program, the initiative to return humans to the moon. They just announced a project called Moonfall.
Moonfall.
They're planning to use a fleet of highly advanced autonomous drones to scout the incredibly rugged, shadowed terrain of the lunar South Pole, flying drones in a vacuum. And simultaneously, Peter Rossoni, a flight manager for the Artemis II mission, successfully oversaw a critical test transferring 450 gigabytes of data using groundbreaking deep space laser communications.
To grasp the magnitude of that data transfer, we have to look at the limitations of traditional space communication. For decades, we've relied on radio waves. But radio waves spread out and weaken over vast interplanetary distances, severely limiting bandwidth. It's why video from Mars is often choppy or delayed. Laser communications, however, use highly focused optical beams of near-infrared light,
Which changes the game.
This allows for a massive, exponential increase in data transmission rates. Transferring 450 gigabytes, which is equivalent to dozens of high-definition movies from deep space, is a monumental achievement in optical targeting and receiver sensitivity. It ensures future lunar astronauts will have real-time, high-bandwidth connectivity with mission control.
I always joke that I can barely get my home Wi-Fi to reach the kitchen, and NASA is precisely targeting a laser beam to transmit 450 gigs of data across the deep space void.
It's quite a contrast.
And it wasn't just NASA actively participating in the Artemis mission testing. Citizen science played a massive role. Volunteers from Earth, sitting in their backyards, successfully recorded tiny flashes of light on the lunar surface, which were meteor impacts during the mission window.
The democratization of astronomy. It proves that the engaged public, equipped with commercially available telescopes and high-speed cameras, can actively contribute vital observational data to complex, multi-billion-dollar space missions.
But getting the payloads up there remains the hardest bottleneck, which is why rocket innovation is so critical right now. Astrobotic just successfully test-fired a next-generation rotating detonation rocket engine.
The RDE. It is a fascinating yet highly volatile piece of aerospace engineering.
I have to ask about the physical mechanics of this, because when I hear rotating detonation, it sounds like they're trying to harness a continuous bomb inside metal tube. How does this differ from the rockets we see launching today?
Your description is actually remarkably accurate. Traditional rockets rely on a process called deflagration. They mix fuel and oxidizer and burn it continuously, creating a hot, expanding gas that is pushed out the nozzle at subsonic speeds relative to the combustion chamber.
It is a controlled, steady burn.
Exactly. A rotating detonation engine, or RDE, operates on a completely different principle. It creates a continuous supersonic shockwave of detonation that chases itself in a circle within a ring-shaped annular channel.
So it's not a burn, it's a literal perpetual explosion spinning in a circle.
Exactly. Detonation extracts energy from the propellants much faster and more efficiently than deflagration. The challenge has always been stabilizing that chaotic shock wave so it doesn't melt the engine block. But Astrobotic's successful test fire proves it is viable.
That is huge.
If perfected, an RDE is significantly lighter, vastly more fuel efficient, and far more powerful than traditional engines. It could completely revolutionize the payload economics of heavy lift space travel.
And the heavy lifters are busy. SpaceX is launching the massive Falcon Heavy rocket for the first time in 18 months to carry a massive broadband satellite into geostationary orbit. And Russia just successfully launched a Progress cargo ship carrying 3 tons of crucial supplies to the International Space Station. The orbital highway is getting crowded.
It certainly is.
But perhaps the most disruptive sci-fi space news of the week involves Meta, the parent company of Facebook.
This development ties directly back to our earlier discussion on the massive energy demands of artificial intelligence.
Meta just signed a formal deal with a company called Overview Energy to develop space-based solar power, SBSP. The plan is to launch massive arrays of solar panels into orbit.
Right.
Because there is no weather and no night cycle in high orbit, they can collect solar energy 247 at maximum efficiency. Then they intend to beam that collected power back down to Earth using highly concentrated microwaves or lasers to physically power Meta's massive data centers at night.
The underlying logic is economically sound, if technologically daunting. As we established, the AI compute revolution requires unprecedented amounts of electricity. The terrestrial power grid is already straining under the load of traditional consumption and the shift to electric vehicles.
So they need another source.
If big tech cannot secure enough stable, continuous power on Earth to run their trillion-parameter AI models, they possess the capital to literally go to space to harvest the sun directly.
But the geopolitical insecurity implications of this are staggering. What happens when a private, multinational corporation like Meta controls an orbital satellite capable of beaming highly concentrated, high-energy microwaves down to the surface of the Earth?
It's a huge question.
That is a power source, yes. But physics dictates it is also a potential directed energy weapon.
It is the ultimate dual-use technology. And this highlights a massive gap in global governance. The regulatory and security frameworks required to monitor and police space-based power beaming simply do not exist yet.
That's concerning.
It will require intense, transparent international oversight to ensure that an invisible microwave beam designed to power a server farm in a desert isn't misconstrued as an orbital strike by an adversary's early warning systems. The potential for catastrophic miscalculation is high.
It is a brave, incredibly complex new world, and just to remind us how small we are in the grand machinery of that world, the Eurosita Space Telescope just captured incredible X-ray images showing our entire solar system interacting with Earth's magnetosphere.
Oh, yeah.
As the solar wind from our sun hits our planet's magnetic shield, the resulting X-ray emissions pulse and shift, making it look in the data like the entire solar system is literally breathing.
A beautiful, humbling visualization of space weather. It reminds us that we are not just floating statically in an empty void. We are sailing through a highly active, energetic, fluid cosmic ocean.
Which brings us to our final segment today. We have talked about the literal breaking apart of continents, the volatile threat of global war, the cold, calculative logic of AI, and the terrifying void of space.
We've covered a lot of ground.
But to truly close out this deep dive, we need to focus on the human biological machine itself, the unyielding human spirit, the incredible ways humans are surviving, adapting, and pushing both physical and social boundaries.
Ultimately, all of this technological and geological context only matters through the lens of human experience and resilience.
Exactly. Let's look at the absolute bleeding-edge peak of human physical potential. Kenyan runner Sebastian Saw just made history. He became the first person ever to officially break the 2-hour barrier in a competitive sanctioned marathon in London, UK.
It is a staggering physiological achievement that forces a reevaluation of human biomechanics.
Right.
For decades, sports scientists debated whether the human cardiovascular system and muscular endurance were even theoretically capable of sustaining the required pace, roughly 4 minutes and 34 seconds per mile, for 26.2 consecutive miles without suffering catastrophic systemic fatigue.
I always compare this to the historic 4-minute mile. For years, the medical consensus was that running a mile in under 4 minutes would literally cause a human heart to explode. The barrier was psychological as much as it was physical.
It really was.
But the moment Roger Bannister broke it, suddenly a dozen other people broke it the following year. How will Saw's sub-2-hour marathon change the psychology of elite endurance athletes globally?
It completely obliterates the paradigm of impossibility. Once the human brain empirically accepts that a physical barrier has been breached, the subconscious neurological constraints that hold the body back begin to vanish. I expect we will see a rapid clustering of sub-2-hour times in the major marathons over the coming decade, simply because the psychological ceiling has been definitively removed.
But running isn't just about elite athletes breaking world records. In parts of the world, running is literally a tool for survival. In the Sebe subregion of Uganda, Coach Zwena Cheptok is using competitive running to protect vulnerable young girls.
Her work is incredible.
She works with local foundations to recruit girls into rigorous athletic training programs to actively shield them from the culturally entrenched practices of female genital mutilation, FGM, and forced child marriage.
The sociological impact of this program is profound. It demonstrates how something as fundamentally simple as running, just putting one foot in front of the other, is being utilized in London to redefine the limits of human biology while simultaneously being deployed in Uganda as an instrument of social revolution. Coach Cheptok is providing a tangible, physical escape route. Athletics grants these girls community support, a public voice, physical autonomy, and economic opportunity in an environment where oppressive gender norms actively seek to subjugate them.
It is empowerment in its absolute purest, most physical form. And on a macro global level, we are fighting for human survival using the very science we developed. The World Health Organization, the WHO, just released a landmark report stating that global vaccination campaigns have saved an estimated 150 million lives over the last 50 years.
150 million.
150 million. It's hard for the human brain to even conceptualize a number that large.
It is arguably the single greatest public health triumph in the history of our species. Diseases like smallpox have been entirely eradicated from the wild, and polio has been pushed to the absolute brink of extinction, entirely due to the collaborative application of immunology.
And we are learning more every day about how to maintain that health on an individual level. A massive new 3-decade study tracking 100,000 people finally proved that a wide variety of physical exercise mixing cardio, strength training, and flexibility, rather than just doing the exact same repetitive workout routine for duration, significantly adds healthy years to your life.
Variety is key.
Variety is literally the biological key to longevity.
It speaks perfectly to the evolutionary design of the human body. As we discussed with the early human populations in Africa, we evolved to navigate complex, shifting environments. Our bodies are designed to perform diverse, complex movements, climbing, lifting, sprinting, walking, not just repetitive, monotonous motions on a treadmill.
Right.
Diverse physical stress creates robust, systemic, biological resilience.
But, and this is the heartbreaking contrast that we must acknowledge, while our scientists know exactly how to extend human life, socioeconomic realities are actively dragging it down.
It's a sobering reality.
The United Kingdom just reported that healthy life expectancy has actually fallen by 2 full years over the last decade. And the data shows this decline is entirely driven by economic deprivation. Poor housing, chronic economic stress, and lack of access to high-quality nutrition are physically aging the population faster.
It is a stark, vital juxtaposition. The UK's falling life expectancy alongside SAW's athletic triumph proves a difficult systemic truth.
What's that?
Human biological potential is incredibly high, perhaps higher than it has ever been in history, but actual human health outcomes are deeply, inextricably anchored to socioeconomic environments. We possess the medical technology to save 150 million lives with vaccines, but if a society structurally fails to provide basic economic stability, the biological foundation of its citizens degrades regardless of the medicine available.
It all comes back to the foundation. If the societal foundation cracks, the house falls, no matter how advanced the technology inside it is.
Exactly right.
What an incredibly intense, illuminating journey we've been on today. We started by walking in 115,000-year-old human footprints preserved in the mud of a Saudi Arabian desert. We explored the tectonic tearing of the African continent, the vanishing upwelling in the warming oceans of Panama, and the high-stakes geopolitical chess match over the critical minerals of the future. We broke down how AI is doing years of deep space math in a matter of days, the physics of rockets that fly on perpetual explosions, and the reality of corporations planning to beam the sun's energy down from orbit.
It's been a lot.
And we ended with the triumph of a man redefining human endurance in London and a coach in Uganda using that exact same sport to save young girls' lives. We promised you at the start that the foundations of our world were shifting, and examining the evidence today, I think we definitively proved it. Thank you so much for joining us on this deep dive.
It is a dizzying, unprecedented amount of systemic change to process, and I want to leave you, the listener, with a final evolutionary thought to mull over.
Okay, let's hear it.
We've seen today how our ancestors evolved from a complex web of intermingling populations, adapting to survive the extreme climate shifts of a harsh ancient world. Today, we are currently building artificial intelligence that analyzes the cosmos in days instead of years. We are manipulating the quantum rules of light to create unbreakable communication, and we are preparing to beam orbital energy down to Earth.
Right?
If we are changing our planet, accelerating our technology, and restructuring our energy sources this rapidly and with this much targeted intention, how long until we use these exact same quantum, artificial, and biological tools to consciously, genetically guide the next physical evolution of the human species itself? Are we, sitting here today in 2026, the last generation of Homo sapiens as we currently know them? If the foundation of our world is no longer solid concrete, what exactly are we going to build next?
Now that is a profound question to walk away with. Stay curious, keep questioning the complex mechanics of the world around you, and we will catch you on the next deep dive.
Enjoying Artificially Informed.
Hit subscribe and share it with a friend.
From the left, the right, and straight from the algorithm.
Thank you.
You know, when geologists study plate tectonics, they often point out that the most dangerous phase of an earthquake isn't actually the visible shaking.
Right. It's the buildup.
Exactly. It's that silent, invisible period right before it hits. It's that moment where the immense pressure of two continental plates grinding against each other it builds up, locking the Earth in this precarious state of immense tension. You look at the surface and nothing really seems to be moving.
But underneath, it's a completely different story.
Right. Underneath, the very foundation of the world is preparing to fracture. Welcome to the debate. Today, we are looking at a geopolitical landscape that is currently locked in, well, exactly that kind of terrifying high-pressure paralysis. Our planetary home is presently caught in this bizarre limbo of no war, no peace.
And the epicenter of that pressure right now is the Middle East. Specifically, we're talking about the dual blockades of the Strait of Hormuz by the United States and Iran. I mean, we are looking at a massive geopolitical shock that has effectively choked off one of the most vital maritime arteries on Earth.
Yeah, it's huge. And the reverberations of that choked artery, they're echoing everywhere, from the coastlines of Latin America to the capitals of Europe and Asia. So the central question we have to grapple with today is this. Is this planetary crisis acting as a necessary, albeit painful, catalyst that is accelerating our transition toward a sustainable multipolar world order? Or, conversely, is it fundamentally fracturing the global economy and entrenching these heavily militarized, isolated power blocks?
Well, I think it's very clearly the latter. We are witnessing a dangerous retreat into resource nationalism. The breakdown of U.S. hegemony isn't creating some collaborative multipolar world, It's creating a zero-sum geopolitical survival game. Everyone is arming themselves to the teeth, and it's fracturing the global economy in the process.
And I take a fundamentally different view on that. While the friction is undeniably severe, I won't argue that. This current crisis is actually a vital catalyst for a necessary global restructuring. The shock to our fossil fuel supply chains is forcing a rapid transition to renewable energy.
But at what cost?
Well, a high cost, sure, but it's decentralizing global diplomacy. As traditional Western hegemony wanes, we are finally seeing the global South and emerging powers claiming agency, and that is paving the way for a much more balanced planetary order.
Well, look, if we are going to talk about a transition, we have to look at the immediate physical reality of the global carbon economy. The Strait of Hormuz is a literal bottleneck.
Right. What is it, about 20% of the world's oil passes through there?
Exactly.
And with both the U.S. and Iran blockading the waterway and the U.S. refusing to renew Russian or Iranian oil waivers, we are seeing an immediate forced evolution in energy technology. History shows us that necessity is the mother of invention, right? Look at China's recent breakthrough in developing an ultra-cheap, all-iron flow battery.
I come at it from a different way. That's a technological achievement, sure, but how does that solve an immediate energy blockade? I mean, people need power today.
Because it fundamentally changes the economics of grid-scale renewable storage. For years, the Achilles heel of solar and wind has been storing the power for when the sun isn't shining. We've relied heavily on lithium-ion batteries, but lithium is, well, it's expensive, difficult to mine, and highly geopolitically bottlenecked.
Right.
Iron, on the other hand, is one of the most abundant materials on the planet, and it's roughly 80 times cheaper than lithium.
Wait, so they're using liquid iron? How does that even work?
Essentially, yes. It uses liquid electrolytes containing iron to store and release energy. It's massive, obviously, meant for power grids, not smartphones. But because it's so incredibly cheap, it makes renewable energy storage viable anywhere on the planet, and we are seeing that deployment right now.
I'm just not sure it's scaling fast enough to replace oil.
But developing nations are already leapfrogging traditional fossil fuel dependencies. Take Cuba, for example. They are heavily impacted by the U.S. blockade and the recent loss of Venezuelan oil. Yet, utilizing Chinese-financed solar parks, Cuba has managed to increase its solar power generation from 6% to over 20% in just 1 year.
Oh, wow. In 1 year?
Yes, 1 year. And if a country like Colombia is now hosting the first global summit entirely focused on transitioning away from fossil fuels, doesn't that show a coordinated shift? Geopolitical pressure is actively severing our reliance on volatile oil.
I hear that, but you're framing pure desperation as innovation. The examples you're citing, they are not part of a coordinated visionary transition to a sustainable planet. They are frantic survival tactics that are just masking profound economic pain.
I see why you think that, but let me give you a different perspective. Isn't the immediate economic friction of higher prices a necessary, albeit painful, forcing function? If we don't experience the pain of fossil fuel volatility, we will never mass adopt technologies like the iron flow battery.
But the problem is the timeline. An iron flow battery in a lab or even a localized solar park in Cuba does not heat a home in London tomorrow. Let's look at the immediate human cost of this energy shock. In the UK, government ministers are currently warning of at least 8 months of sustained higher prices across the board.
Right, the logistics costs are surging.
Exactly. That is a direct hit to working families who rely on affordable energy for basic goods. Developing nations simply cannot instantly transition their entire infrastructure to solar or wind.
Because of the immediate infrastructural deficit, you mean?
No, because of the basic chemistry required to keep their populations alive. Look at India. Right now, they are being forced to secure stable fertilizer imports by starting a massive urea production facility with Russia.
And just for our listeners who might not follow agricultural chemistry, why does urea tie them to Russia specifically?
Because urea production isn't just mixing dirt and water, right? To make ammonia, which is the base of modern fertilizer, you need massive amounts of hydrogen. And right now, the only viable way countries like India get that hydrogen at an industrial scale is by stripping it from natural gas.
Ah, so the gas supply is everything.
Exactly. If you cut off the natural gas, you literally cut off the fertilizer supply. If India doesn't have fertilizer, their agricultural sector collapses and people starve. The reality of the Hormuz blockade is that it's forcing nations into awkward, immediate alliances with whoever can provide the baseline carbon and chemical resources required for survival.
But wait, isn't that exact friction the only thing that actually forces a paradigm shift? I completely acknowledge the agricultural panic in India and the cost of living spikes in the UK. But global energy paradigms do not shift voluntarily. They just don't. They shift when the incumbent system becomes too expensive or too politically volatile to sustain.
You're saying the pain is the point. I'm saying the pain is the mechanism. The short-term pain is exactly what prices fossil fuels out of the market and forces capital into renewable infrastructure. If Cuba can triple its solar capacity in 12 months under intense embargo pressure, it proves that the transition is a matter of political will. This crisis is finally generating that will.
That assumes the political will is directed solely toward building solar panels. But, this frantic scramble for energy doesn't happen in a vacuum. When countries are desperate to keep their lights on and their crops fertilized, they don't care about green transitions or traditional alliances anymore. They buy guns, and they make deals with whoever has the resources.
You think militarization is the main outcome here?
Let's look at the defense spending. According to the Stockholm International Peace Research Institute, global military expenditure has just hit an all-time record of $2.89 trillion. European military spending alone surged 14% to $864 billion.
Wait, let me stop you there. $864 billion in European defense spending is a staggering spike. But are they building these militarized fortresses because of the threat from Iran or because the traditional security umbrellas are failing?
It's because established security frameworks, specifically NATO, are absolutely disintegrating under the pressure of this blockade. The U.S. is demanding compliance and Europe is balking. We have reports of an internal Pentagon email suggesting the U.S. might seek to suspend Spain from NATO for insufficient support in the Middle East.
Suspending a core European member over a regional disagreement? That's intense.
Exactly. And it gets worse. Number 10 Downing Street recently had to publicly reaffirm UK sovereignty over the Falkland Islands. Why? Because a leaked U.S. memo suggested Washington might withdraw its historical support for London's claim to the Falklands, explicitly to punish the UK for not joining the Iran conflict.
So they are weaponizing a totally unrelated territorial dispute in Latin America to force European compliance in the Persian Gulf?
Yes, it's a textbook example of diplomatic blackmail. When the United States is willing to threaten its closest European ally over a territorial dispute an ocean away, the alliance system is breaking. And into that vacuum, you have new, highly militarized blocs forming.
Like who?
While Russia and North Korea just signed a long-term military cooperation agreement lasting until 2031. Meanwhile, Russian mercenaries are withdrawing from a destabilized Mali amid coordinated jihadist attacks, leaving another power vacuum in Africa. This isn't a transition, it is planetary fragmentation.
That's an interesting point, though. I would frame it differently. If the U.S. is alienating allies to the point of threatening the UK over the Falklands, doesn't that inherently force Europe and the global south to develop the independent strategic autonomy you claim they lack? Isn't this the end of unhealthy unipolar dependency?
Unhealthy, maybe, but it provided stability.
An illusion of stability, I'd say. If the U.S. can weaponize alliance structures to dictate European foreign policy, then Europe never truly had strategic autonomy to begin with. What we are witnessing isn't just destruction, it's the breakdown of unipolar dependency. It's forcing the emergence of a much more mature, multipolar diplomacy where nations have to actually negotiate instead of just falling in line.
But where are you seeing this mature negotiation?
Everywhere the U.S. is stepping back. Because of this crisis, the U.S. canceled envoys Steve Witkoff and Jared Kushner's planned trip to Pakistan for peace talks. Under the old system, that would mean a diplomatic freeze. But who filled that void?
I am assuming not a Western power.
Right. Iranian Foreign Minister Abbas Araghchi immediately engaged in regional diplomacy, traveling to Pakistan, Oman, and Russia. He is actively seeking a framework to end hostilities through regional neighbors rather than waiting on Washington.
But regional diplomacy, led by a blockaded nation, isn't exactly a recipe for global stability.
It is a recipe for regional agency. And it's not just the Middle East or Asia. European leaders are finally speaking out and charting their own course. German Chancellor Friedrich Merz bluntly stated that the U.S. is humiliated and lacks a strategy. Albanian Prime Minister Edi Rama went on record warning that isolating Russia is a big strategic mistake, arguing that continuous dialogue is the only path to resolution.
So you see this as a positive?
Yes. What you see as the destruction of alliances, I see as the rest of the planet, Europe, Asia, the global south, finally asserting independent diplomatic agency without waiting for permission from a single superpower.
I understand the theoretical appeal of independent strategic autonomy. It sounds incredibly empowering. But we have to look at the physical reality of how these newly autonomous nations are interacting. They aren't building a cooperative multipolar network. They are building hostile economic fortresses.
Fortresses in what sense? Trade is still flowing.
Barely. Let's talk about the physical manifestation of global trade. Because of this no war, no peace standoff, the UN International Maritime Organization has issued a dire warning,
There are currently 20,000 seafarers stranded on 2,000 ships in the Persian Gulf. Human beings are trapped in a maritime choke point because the basic planetary agreement of freedom of navigation has collapsed.
Yeah, that situation is deeply concerning.
We aren't just seeing a disruption in trade. We are seeing the end of the just-in-time global economy.
And the birth of the just-in-case global economy.
But just in case means hoarding. Trade itself is being explicitly weaponized. The US and the EU just signed a massive critical minerals pact. It's not just about standardizing mining practices, you know? It's explicitly designed to loosen China's grip on the supply chains required for modern technology.
Which, again, builds redundancy. If China controls all the rare earth minerals, a single geopolitical shock could paralyze Western tech.
But China doesn't just sit back and watch that happen. They retaliate. We just saw Beijing step in and reverse Meta's acquisition of the AI startup Manus. When critical minerals, shipping lanes, and artificial intelligence acquisitions are all treated as matters of national security, you no longer have a global economy.
You think it's entirely broken down?
You have a series of walled gardens where nations hoard resources and block technological integration. You can't have planetary innovation if half the world refuses to share microchips with the other half.
But despite all of those structural pressures, the stranded ships, the mineral pacts, the blocked tech acquisitions, global markets are proving to be remarkably resilient and forward-looking.
Are they resilient, or are they just detached from reality?
They are pricing in the new reality. We are in this incredibly tense geopolitical limbo, yet both the S&P 500 and the NASDAQ recently closed at record highs. And what drove that? It wasn't traditional, globally integrated supply chain companies. It was boosted by domestic tech giants and chip manufacturers like Intel. Capital is not fleeing in a panic.
So it's just staying home.
Exactly. It understands that the era of hyper-globalized single-point-of-failure supply chains is over. The market is efficiently reallocating capital toward domestic manufacturing, artificial intelligence, and technological innovation. The surge in these indices suggests that the planetary economy is highly adaptable.
I'm sorry, but I just don't buy that. Let me tell you why. A soaring stock market driven by a handful of domestic chip manufacturers doesn't negate the reality of 20,000 human beings stranded at sea, or the fact that the U.S. won't renew Russian or Iranian oil waivers. Market exuberance is not the same as planetary economic stability.
How so? If Intel is building new foundries, that's real concrete being poured and real jobs being created.
Yes, but we have to separate the financialization of the economy from the real economy. The fact that capital is flooding into Intel or AI startups doesn't solve the fact that developing nations are facing localized inflation or that the UK is bracing for 8 months of elevated prices for basic goods.
But those elevated prices are a temporary adjustment period as supply chains localize.
They aren't temporary if the fundamental structure of trade has become less efficient. When the U.S. refuses to renew those oil waivers, the cost isn't borne by tech investors in Silicon Valley. It's borne by working-class populations globally who have to absorb the shock of higher logistics and energy costs.
Right, the consumer pays the price.
Always. The stock market is cheering the building of these economic fortresses because building fortresses requires lucrative domestic government contracts. Defense spending and subsidized domestic tech enrich shareholders, but a world of walled gardens is inherently less efficient, more prone to conflict, and fundamentally more expensive for the average citizen.
I understand the concern about efficiency, but you are treating the old system of hyperglobalization as if it were a flawless baseline. The old system was efficient, yes, but it was incredibly fragile. We optimized for cost at the expense of resilience, and we relied on a carbon infrastructure that tied our economic fate to the most volatile regions on Earth.
It kept prices low, though.
The efficiency of the past was subsidized by ignoring geopolitical vulnerabilities. What you call building fortresses, I call building lifeboats. By localizing supply chains and forcing a transition to renewable grids, whether that's via iron flow batteries in China, solar parks in Cuba, or new chip foundries in the US, we are actually insulating the real economy from future shocks.
But lifeboats and redundancy require massive overlapping investments, which brings us right back to the weaponization of the planet. If every geopolitical bloc has to build its own redundant supply chain for critical minerals, its own independent energy grid, and its own sovereign AI infrastructure, the competition for the raw materials to build those separate systems becomes a flashpoint for conflict.
You're saying redundancy creates resource wars.
Exactly. That's why the defense budgets are at $2.89 trillion. It's why the US and EU are forming critical mineral pacts against China. There is a finite amount of copper, lithium, and rare earth elements on this planet. The transition you are talking about, a smooth, decentralized shift to a green, multipolar world, requires a level of planetary cooperation that simply does not exist when nations are simultaneously fighting proxy wars and blockading shipping straits.
It's a tough environment for cooperation, for sure.
You cannot have a seamless green transition while you are actively locked in a no-war, no-peace standoff that is bleeding the diplomatic trust out of the international system.
Well, I think we have clearly mapped the boundaries of our disagreement today. From my perspective, the current geopolitical shock radiating from the Strait of Hormuz is the friction required to break the paralysis of fossil fuel dependency and unipolar dictates. It is undoubtedly turbulent, and the localized economic pain is very real.
Highly real.
But it is forcing profound, necessary innovations, like the democratization of energy storage through iron batteries, and it is empowering nations from Colombia to Pakistan to assert their diplomatic agency. The pain of the present is the catalyst for a much more resilient, decentralized planetary order.
And my perspective remains that the illusion of a coordinated transition completely ignores the stark reality of a fractured world, a newly emerging multipolar order that is built on a foundation of record-breaking $2.89 trillion military budgets, stranded global shipping, and the aggressive weaponization of essential resources and alliances is not sustainable. We are not transitioning to a better system. We are reverting to a dangerous era of zero-sum militarization, where global cooperation is being sacrificed for regional survival.
If there is a point of convergence between us, it is the mutual recognition that the era of uncontested U.S. hegemony and the seamless hyper-globalized trade system it oversaw is definitively over.
Absolutely. That era is gone.
The tectonic plates of our global architecture have shifted, fundamentally altered by the crisis in the Middle East and the shifting priorities of the global South, Europe and Asia. Where we remain in deep disagreement is whether this new multipolar landscape will ultimately be defined by sustainable, decentralized innovation or by hostile, zero-sum militarization. As we evaluate these planetary shifts, intellectual charity is essential.
It really is.
Understanding the mechanics of our new reality, whether we are analyzing the sudden vulnerability of the Falkland Islands, the chemical realities of Indian agriculture, or the choked waters of the Strait of Hormuz, requires viewing the planet through multiple lenses. There is much more to explore in the shifting currents of global diplomacy and the immense pressures building beneath the surface of global markets. We leave it to you to form your own conclusion on the trajectory of our planetary home. Thank you for joining us.
That's it for today's Artificially Informed.
Nope. Thanks for spending your time with us.
Yeah.
Stay sharp, stay curious. See you next time.